Hey guys, this is lesson 1, and if you've already tried it, then you know that it is really hard. You can watch his video if you want. I'm hoping that this will help clear some things up for you guys. And so let's start. I'm going to be referring to my notes a lot because this is a lot of stuff and it just helps to jog my memory. So I'll start by drawing the propene oxide. If you don't know what these are, you can go and look at his video. I'll try to explain it briefly as I go through this. But basically, I'll just do it. So there would be like you see the ene, so there'd be a double bond, but then there'd actually be, instead of that bond, it would actually be an oxygen in between that. So that's basically what we're doing. So what I like to do is draw it like that, and then change the top carbon to an oxygen. So now I have my propene oxide, and last thing I need to do is make sure that it is as conformation. So I'm going to put that hydrogen in the back because this is my chiral center. And then this is my first priority, my second, and my third. It's going counterclockwise, so this is the S conformation. I'm pretty good at that now because I've done this homework so many times. And lastly, okay, so we're going to start with this CH3MgCl. So I'll put my C on the canvas, and I'm just going to add the Cl to it. Because ultimately the carbon is going to be the one that's going on here. So what I figured out with the carbons, so you see this one has 2 carbons here and this one only has 1. Well, we're going to disconnect this oxygen. When it says hydronium workup, or when you're attaching a carbon, you're going to want to attach it to the one carbon that doesn't have another carbon attached. So we're going to do it here. If it said acid catalysis, then we're going to want to disconnect this here and attach mostly like a chlorine or an oxygen, anything here. But since it says hydronium workup and we have a carbon that we're going to attach, we're going to detach this oxygen from the single carbon, and then I'm going to take this bond over here and attach it to that carbon. Now I'm going to move this carbon to the bottom, and then it's a hydronium workup, so I'm going to add a hydrogen to this oxygen. So hydrogen, use my heterolytic function and attach that. And then I'm going to delete this chlorine on the side. Now I'm going to put arrange. Okay, and this is what it should look like. And keep in mind, I haven't quite mastered this lesson yet, so some of these I might get wrong because there's still some that come up that I just can't figure out, but I have a notebook of all my wrong answers and of my right answers. So I recommend, if you're doing this as well, to keep a notebook, one for wrong, one for right. Okay, I'm gonna make that propene oxide again, add my oxygen to the top, add my hydrogens and hit arrange. And now I'm gonna look for the conformation. I see this is my chiral center, my hydrogen's in the back. I have my oxygen first priority, second, this one, and then third. This is going right there to the right, so this is our conformation. So all we have to do is press mirror, and this is what we get. Once you go through these homeworks, this will be like the easiest thing to figure out what's S and what's R with this particular molecule. Lastly, okay, sorry, not lastly. We're going to do the potassium hydroxide. So I also have a list of like what everything is, because there's like, I think methyl cyanide or sodium cyanide, different things. So I have it, sodium methoxide. I just have it on here so I can see exactly what it is, and I don't have to Google so much because I found myself using Google a lot. I'm just looking up. I didn't draw my potassium hydroxide. There we go. So I'll add my hydrogens. Okay, and then I'm going to release that. and I see hydronium workup. So more than likely it's gonna be right here, because this is where the hydronium, this is where they go. When it's acid, you want to use these two. When it's hydronium, more than likely you want to use this one. And let's see, let me refer to my notes. Okay. I don't think I have this one, so let's see. I don't have this one, so we're gonna see if it's right. Let's see. So I'm going to detach that oxygen, and then I'm gonna put this one down here. And again, I'm gonna move it so it doesn't end up on the top. For some reason, you want it on the bottom. And then I'm gonna change this potassium to a hydrogen, and then use my heterolytic function to grab that and place it on my oxygen on top. Let's see if that is right. Okay, I'm just gonna add that really quick to my notebook. Hydronium. But yeah, you're gonna want to keep a notebook. This homework was really hard, so I'm just trying to keep all my answers together. Okay, I'm gonna draw the same propene oxide, change that carbon on the top to an oxygen, add my hydrogens and hit arrange. Oops. Okay. Fit, roll. This is, I can already see it's S, but you always want to make sure. I got comfortable in the beginning and I kept thinking I knew what it was, but just keep an eye on the hydrogen and make sure that if it's in the front, even if it's facing this way, but if the hydrogen's in the front, that makes it R. So just make sure your hydrogen's in the back whenever you're looking at it. So 1, 2, 3, S. So I'll move that there, and then I have my hydrogen chloride. So I'll just put a chloride. Okay, I think I do have this one. I have ether oxide. And what I was doing before was I was trying to include this diethyl ether, but you actually don't need it. I think it's more of like an acid catalysis, like an indicator that that's what you're doing. Okay, I don't have it in my notes, so let's just go for it. So I'm thinking that this is an acid catalysis, so I'm going to take this oxygen off and use these two, because that's what we use for the acids. And then I'm going to use my heterolytic function, attach that carbon to the chlorine. And then I have this hydrogen left, and I'm going to go ahead and grab that for the oxygen. I don't know if this is right, because I think this is one that I got wrong, and I was still trying to figure it out. Let me check my notes one more time. I think the reason I got it wrong was maybe because the chlorine and the hydrogen are in the wrong position, but I haven't done this. I've done it a lot. I haven't done it enough to figure it out, but let's see. Okay, so the next one I try is more likely I'm gonna switch that, if I remember. Okay, so I've got my propene oxide. I'm gonna add my oxygen, and then add my methyl to the 2 position. add my hydrogens. There's no conformation, so I don't have to worry about that. And then I have hydrochloric acid. So I have my chlorine, and I'll add my hydrogen to that. Most of the time when you have a chlorine, you're going to add it to the bulk of the carbons, so not to this one. I noticed that usually when you attach this carbon, it's for the hydronium workup, and it's usually just carbon, oxygens, and nitrogens. Oxygen can be bonded here, but most of the time when you're bonding over here, you use carbons a lot. So let's go ahead and attach this over here, detach this oxygen, and go ahead and take that hydrogen. I'm going to move my chlorine. And the bad thing about this homework is that I think it really matters where these go, but sometimes it's hard to move it, and it's hard to like remember what you did wrong the last time. To try to figure out, okay, was it in the wrong position? Was it just completely in the wrong place? So this homework stressed me out. Okay, I'm surprised that was right. Oh, you're gonna love these. So these are the easiest ones. Whenever you have an ethene oxide, you're just gonna do this little triangle, put the oxygen on top, add your hydrogens. These are like the best. Trust me. So all you're gonna do, I usually take from the side. I've been doing that. I haven't switched it up because I've been doing it a lot. But I'm gonna go ahead and attach my nitrogen, take this hydrogen, and then I'm just gonna move this nitrogen down along with that hydrogen. Arrange and fit. And then what I just double check is that the nitrogen is all happy. So this counts as 1, 2, 3, and then the lone pair is 2, so that's 5. And that's what it needs to make it happy, is 5. So that looks good. But yeah, those ethene oxides, these are the best ones. You really don't have to think much. Okay, again, I'm going to add that oxygen. I have my hydrogen chloride, so I'll add my chloride on the side, add my hydrogens, and use my heterolytic function to remove that bond from oxygen and carbon. And now I'm going to move this bond and put it on this carbon. I'm going to grab that hydrogen. And lastly, I'm going to move the chlorine down. Hit arrange. I'm not going to double check my notes. I'm going to see if they really are that easy. Okay, so yeah, these are the best. Okay, so we got that S propene oxide again. So got my triangle with a little carbon sticking out, and I'm going to change that oxygen on the top, and then I'm going to add my hydrogens, hit arrange. Oops. Okay, I turned it around so that my hydrogen is in the back, and this is actually the S conformation. We've got 1 priority, 2nd, 3rd. It's going counterclockwise, so that's S. I like to move it to the side, and then now I'm going to add my methanol. So I got my, let's see, oxygen, carbon, and my hydrogens. Okay, so I see acid catalysis. So I'm most likely going to bond this one to these two. Well, this one, but not the carbon that doesn't have another, like 3 carbons, or 2 carbons attached, I should say. So I'm going to use my heterolytic function, it's acid catalysis, so I know it's going to go to the bulk of the carbons. And I'm going to take the bond that has the hydrogen, and then I'll go ahead and move that. And I'll go ahead and grab that hydrogen. Hit arrange. And I'm going to double check on my notes. It looks to be about right. So let's see. Okay. Okay, we're drawing the same thing. Okay, I'll show you at the end if I don't get one yet. I have one that I want to show you guys, and it was probably the hardest one for me. Okay, I got my S. Well, I don't know if it's S yet. Okay, my hydrogen's in the back. I know this is R, so I'll go ahead and mirror it. Okay, that's what I want to see. And then methanol, so I've got my S and my carbon. I'm going to add my hydrogens. I see that it's an acid catalysis, so I know I'm going to use the bulk of the carbons, so this side. Remember, the single one is just for hydronium workups or to attach other carbons, and then this one is to attach oxygen, sulfurs, chlorines, things like that. At least that's what I like, the trends I learned from doing the homework. So I'll move that bond, put it on the oxygen, and now I'm going to use this one, attach it to this carbon. I'll go ahead and grab that hydrogen, and I'm going to move the sulfur and the carbon down. Hit arrange. Okay, that looks about right. I'm not going to check my notes, I'm just going to go for it. Okay, methyl propene oxide. So I've got my 3 carbons and then the little leg hanging out. I'm going to change that top carbon to an oxygen, and then I'm going to add my methyl on the 2 position, add my hydrogens, and I can leave it like that because there's no R as confirmation that it specifies. And then I have my sodium acetylide. I think I have that. No, I don't have it. Okay, so that is carbon, carbon, triple bond. I'll add my sodium. Arrange. I don't know if you guys can hear my notifications on my work. Okay, so it's a hydronium workup, and I know I'm going to attach the carbon. So we already know that's going to be the single carbon, not the bulk, the single. And then there's 2 hints. So there's a hint hydronium workup, it's going to be the single one, and that I'm attaching a carbon. So I'm going to detach that oxygen. I'm going to attach the carbon. I'm going to move it to the bottom. And then I'm going to change that sodium to hydrogen. And then lastly, attach that hydrogen to the oxygen. Hit arrange. Okay, that looks about right to me. I'm going to check my notes just to make sure. What is this? Sodium acetylide. I don't have it, but let's go ahead and go for it. Okay. I'm doing my propene oxide. I'm going to add my oxygen to the top, add my hydrogens, hit arrange. Okay, and now I'm going to roll it around. This is our confirmation. 1, 2, 3, right there to the right. Gonna move it to the side a little bit. Hydrochloric acid, I'm gonna add my chlorine. add my other hydrogens. And this is an acid, so I'm gonna go ahead and use this side. Because acid catalysis kind of seems like it would make sense. So I'm gonna move these around, grab that hydrogen, move this to the bottom, arrange. And remember with the chlorines, I'm always like super unsure of exactly where the chlorines go. That's the hardest part. But let me see if I have it in my notes first. What is this? Hydrochloric acid. Okay, let's just go for it. I don't have it, but this chlorine is the one that stresses me out. Okay, awesome. Okay, I didn't get to show you guys. Let me see if I can show you really quick. Okay, so there's one and it'll say, oh, last semester. Okay, there's one and it'll say, well, there's several of them. Okay, it won't let me do it, but it'll say cyclohexane, the product of cyclohexene, oxide, methanol, acid catalysis. So there's a lot of these that'll say cyclohexene. And if you write only one, or if you draw only one, you'll get it wrong. So like for that one, for the methanol and acid catalysis, what you're gonna wanna do is draw. So you're gonna wanna draw this, and then you're gonna wanna draw another one. So for this example in particular with the methanol, we're gonna have an oxygen, 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 oxygen. These two on the bottom are gonna have a methyl attached. And then we can go ahead and roll this around and add a hydrogen up here, hydrogen down here. Oh wait, no. Hydrogen down here. This one's gonna be down, this one's gonna be up. Okay, so let's see if that will go the right way. So the main goal, you see this one went to the back, this should be on top. But the main goal is to have these two molecules, exactly how I drew them, but with one with the hydrogen in the back and this OH in the top, and then this hydrogen on top, and then this group on the bottom. And then this is going to be the opposite. So the hydrogen is going to be on bottom, this one's going to be on top. This one doesn't show it, but this hydrogen should be on top, and this one will be on bottom. If you don't draw these two, you will get them wrong. But yeah, that goes for all the cyclohexanes. So I hope that helps. I'm sorry it's a little long, but good luck.